Everyone. This week we'll begin Chapter 5, How do Risk and Term Structure Affect Interest Rates? Okay, so to begin with, talk a little bit about default risk and the risk-free rate. So if you've heard the risk-free rate before, that is usually the 30-day government bond, or they call it the T-bill. It's usually used as the risk-free rate because the government has never defaulted on that. And then there is a risk premium that is the difference between what you would get on any other bond and that risk-free rate, which the risk-free rate is usually very small. And this is due to a default risk. So, of course, when you buy a corporate bond, companies have a certain probability of defaulting, which means you lose on what you spent on the bond and don't get anything back. And this has to do with risk. So the more likely that a corporation is to go bankrupt, investors, in order to take on that risk, demand a higher return or a higher risk premium. And this is one of the fundamental laws of finance, is this relationship between risk and return. Obviously, it's widely accepted that people, especially investors, are risk averse. So they don't like it, all else held equal. So they have to be compensated for that in order for them to buy a corporate bond. And there are several agencies that give a credit rating or a bond rating for corporate bonds, like Moody's or S&P. There's a couple more, I can't think of them off the top of my head. This is just a little table here from the book, and you can see some companies that you probably recognize here. And this is just important to understand that this can change. Obviously, I don't know how old this is, but I don't believe Netflix is any longer a B. And Sears was at one point definitely was not rated that low. They were probably in the A range. So this can change as news about earnings and things like that are made public. And down here, the book defines this as below a triple B or BAA. It's called junk bonds, but I think that can change too depending on the rating agency. But in general, junk bonds are those that are very speculative, are very risky, and have a reasonable chance of defaulting, and thus they are. You can earn a high return on them, but also you could lose everything. And for liquidity, we've talked about liquidity already. And the important thing to understand about that is the less liquid. The people do not like less liquid. They prefer more liquid. So as liquidity goes down, the risk premium is going to go up. So it's similar to risk there, where the investors are going to demand more. And the reason being, if you want to sell something and you can't for a couple days, the returns that you might get on that might change, and that is not preferable. So the risk-free rate or the 30-day T-bill is the most liquid bond that you can buy. Now on to term structure of interest rates. They talk about a yield curve, which is just the change in the interest rate or the yield depending on the maturity length or the time until maturity. So actually I pulled this table here today, this morning, and this just shows the over the last week or so, the government bonds. So that first one there I circled is the risk-free rate. And as you can see, it's much lower than if you go all the way over here to the 30-year. So as you can see, this is a monotonically increasing in the length to maturity. So that results in an upward sloping yield curve, something like this here. Next, the book talks a little bit about expectations theory. And this is just the theory that interest rates on a long-term bond will equal an average of the short-term interest rates that people expect to occur over the life of a long-term bond. This is pretty intuitive, and it assumes that bonds with different lengths to maturity are perfect substitutes for each other. And they give this equation here, which it might actually make it look more complicated than what it is. It's really just a simple average. So we've seen the T subscript before. That's in each time period. N is the total amount of time. And then this E here, that's just there for expectations, because we don't know what it's going to be in time t plus 1 or next period, but we do know, as you notice, it's not here. That's because we know what that interest rate, it's not expected, we know it. So yeah, they give an example of the book of just calculate this if over the next 5 years the expected rates are 5, 6, 7, 8, and 9%. Obviously the average of that is 7. So that's pretty simple. Next, they talk about market segmentation theory. And this is just kind of the opposite of expectations theory, which is that different bonds with different rates of maturity are not perfect substitutes, so they don't change the demand, the shift in supplier demand among one another. This is, I don't think this is really the case in real life. I think if you see changes, for example, of the risk-free rate today, it's going to affect the 30-year rate. So I guess that's why they call it a theory. And there's no examples that go along with that. And then liquidity premium theory is, since we've already seen expectations theory and we know about liquidity, it's pretty simple. All they have, if there's a liquidity premium that they define here, we just have to add it at the end. So in that example of 5, 6, 7, 8, and 9% over the next 5 years, they say, oh, well, if there's a 5-year liquidity premium of 1%, then again, calculate the average today, and you just add that. So the answer is 8%. Finally, I want to go over one example here, which is a little more complicated. So a customer asks a bank if it would be willing to commit to making a customer a 1-year loan at an interest rate of 8% 1 year from now. To compensate the bank for the cost of making the loan, they will need to charge an additional 1% over the expected interest rate on a treasury bond with the same maturity. If the bank estimates the liquidity premium to be 0.4% and the 1-year treasury bond is equal to 6%, while the 2-year rate is 7%, should the bank offer the loan? So the first step here is to forecast interest rate. So this is somewhat similar to the idea of, or I guess it builds on the idea of expectations theory. That is if a longer term rate, if you were given a longer term rate and today's rate, what is the rate that makes them equal, which is this equality here. So they give this equation. So the blue here is the 1 year. So let's assume that, just as a quick example, that the 1-year rate is 5%. And the 2-year rate is 5.5%. That's the part in orange here. So this is really asking to calculate what does next periods have to be for these two to equal each other. So the first thing we can do here is add the 1 to the other side, which cancels this out, this -1. And then since we're solving for green, we want to divide over blue. And this results in this equation. And this is the same here, so this is just squared. And then lastly, we can divide over 1. So again, this is what we want to solve for. And in this example here, we know that the top is our 5.5%. And the bottom is the 5%. And this turns out to be 6%. So again, so if you plug this back in here, this makes, if I earn 5% this year and 6% the next, that's the same as earning 5.5 this period and 5.5 next period. Okay, so back to this question here, this example. So the first thing we need to do is calculate that. And we have our formula. So let me just rewrite that. So this that example was 2 periods. So in a more general form, if it's multiple periods or n periods, that same formula that I used turns out to be as follows. And here we also, since there is a liquidity premium, we can follow the same logic here that we have to add or subtract it. Okay, and again, this all follows from this forecasting interest rates, from the idea that if I earn 5% today or whatever it is, and I earn 5.5 over 2 periods, then what do I need to earn in the next period for these to equal, for it to be equivalent returns? So in this example, obviously you can think of it as you work for a bank and you're trying to calculate, are you going to make a profit or are you not going to make a profit? So here the problem gives us the interest rate a year from now is 8%. And you have to compensate an additional 1% to make a profit. So here we have the 1 period interest rate for the first period is 6%. The second period ,7%. The liquidity premium next year, here, so the question stated the liquidity premium is expected next year. So this year, today, is 0. The next period, where t equals 1, is 0.4%. And obviously the number of years is 1. So again, this is a more general, it can look more complicated, but this is a more general formula. But again, this is a two period instead of 3 or 4 or 5. So to plug this all in, 7.2%. So that is what it's going to essentially, this is sort of, you can think of it as the opportunity cost of the bank. So they could be doing something else other than offering that loan. Like they could invest in themselves if they wanted to. In addition, it says that they need plus 1% in order to make a profit equals 8.2. So would they want to offer one for 8%? The answer is no, they would not, because they could earn more money at 8.2% by not doing that. And that's all. If anybody would like to see any other examples or have any other questions, please let me know.